NASA has made an effort to recruit astronauts, decades into deep space, and currently it appears that objective will soon be accomplished after conducting numerous tests. Many have failed over the years, but some are progressively demonstrating their ability to aid our improved space exploration. As we moving forward, we'll walk you through the NASA's experiment timeline, conducted, and how they ultimately surfaced with this amazing lightspeed device that startles everybody and frightens some. Space offers countless opportunities, and numerous items we consider to be the impossibility will be proven achievable when we ultimately discover the galaxies that are beyond this. Means that NASA's ongoing efforts remarkable, and a lot of people want to know how they carry out their actions. If you're please come along as we investigate how NASA creates the fastest possible light speed engine to defy physical laws. The significant difficulty when putting people into space is so vast in and of itself. Vast, which is why researchers developed the idea of light years alone elucidate them. Light year defines the annual distance that light can travel, approximately 10 trillion or 6 trillion miles. For example, light takes kilometers. From the moon, it takes roughly 1 second. The moon appears as one light to our eyes. Conversely, a moment away, sunlight travels to us in roughly 8 minutes. Putting the Sun 8 minutes ahead of schedule. Star system Alpha Centauri is the nearest. Is 4.3 light-years distant from the object. Billionths of solar systems may exist beyond ours, light-years away, which is why when astronomers study far-off objects, in essence, they're gazing back at scientists have been attempting to determine a way to move at such a phenomenal speed. Of Elon Musk's SpaceX intends to populate Mars, but the trip takes a few months, or perhaps nearly a year, based on the positions of the planets traveling at the speed of light. The journey could be completed in under 4 minutes. But to move more quickly, we need more kinetic energy, and it requires a massive energy required to accomplish. Even a small drive is a fraction of the speed of light. For instance, a gadget with a tapered copper cylinder with a radiation resonator microwave standing caused by an internal field waves to reverberate around it employs using microwaves to generate propulsion without conventional fuel. That alters the game, because traditional rockets need to be very heavy. To advance, Roger Scheuer, the of mass, the creator of drive, asserts that thrust occurs as a result of differential radiation pressure exists between its ends. However, this justification violates the rule of momentum conservation unless those photons that break out of the device turn it. Even if they were to transform into a photon thruster, make the push. Is NASA's Tiny Eagle Works Laboratory for Advanced Propulsion Physics attempted to match Sawyer's dimensions in numerous tests, but none of them have conclusive. They even took the most recent exam in a vacuum environment to eliminate thermal convection, altering the outcomes. The torsion balance was utilized to gauge any force precisely. The outcomes revealed a constructive push at various powers levels, but it remains far less than. Scheuer asserted that even at its finest, insufficient power to operate hoverboards, alone time-traveling devices, but it potentially beneficial for long-range space travel because it removes the requirement for propellant. Numerous scientists are still working today doubtful of the drive's capabilities, and experiments revealed that earlier positive outcomes were a result of outside forces. However, this is where things get intriguing. The warp drive was an idea that appeared to science fiction, has demonstrated potential. Eric Lentz is a skilled physicist, has been putting forth effort to make it happen. Although he wasn't the first, his contributions, if successful, the warp drive's potential could fundamentally alter how we perceive the cosmos and space exploration. A Mexican mathematician from 1994, Miguel Alcubierre, ignited the entire warp drive conversation with his suggestion, presently referred to as the Alcubierre warp drive. But it's crucial to keep in mind that Alcubierre did not intend to create a rather than the spaceship propulsion system. He was stepping into the domain of theory physics and investigating the options permitted under Albert Einstein's overall relativity theory in the early 20th century, and Einstein's revolutionary theory presented the notion that the fabric of time and space are not static. They can warp and flex when energy is present, and importance of this groundbreaking idea was a cornerstone of contemporary physics, drastically changing our comprehension of the cosmos. Alcubierre's brilliance was in utilizing these conceptual ideas and advancing them to their boundaries. He questioned if it possibly manipulable spacetime to enable more quickly than travel of light, essentially producing a quick cut across the universe. His theoretical structure included the formation of a warp field or bubble surrounding a spacecraft, that spacetime would wriggle in a particular, in this way compressing space would be this warp field. As the spacecraft expands, behind it producing a propelling effect in front without requiring traditional rocketry propulsion, as though he had discovered a method for floating on a spacetime wave curvature. Now that the work of QBR was created, not only the revolutionary, but also the boldness of the concept, as well as the reality that it was a respectable remedy for the field equations of Einstein. The general mathematical foundation relativity was, in general, a legitimate interpretation of the theory, despite it depended on speculative ideas, such as unusual material possessing negative energy density proposal, allowed for conversation to begin. Regarding the possibility of quicker than the idea of light travel has long have been the subject of science fiction work, attracted the interest of both the science fiction and the scientific community enthusiasts, resulting in a large amount of conversations and arguments. One of the largest obstacles are the prerequisite for unusual material with this unusual negative energy density. Matter is essential to the warp's creation bubble that enables spacecraft to move at warp speed, but there is still exotic matter exclusively conceptual and has never been noticed in the environment. Furthermore, the energy requirements of a warp drives are extremely quiet. In actuality, the initial calculations of Alcubierre said that more energy would be needed. Greater than the whole observable cosmos has the capacity to propel even a somewhat sized starship, while later research endeavors tried to lessen the need for energies. Stayed distant from another useful mystery is the causality question, and warp drives paradoxes have the capacity to produce time-like closed curves, providing time travel paradoxes, such as Grandpa. Paradoxically, solving these paradoxes present a major difficulty, but recent advances have restored faith in warp drives. In the midst of these difficulties, Pose for researchers at the Laboratory for Advanced Propulsion at Applied Physics has put forth a fresh model that differs from a real warp drive. Earlier ideas that were dependent on unfavorable energy or strange material model makes use of the actions of bubbles in spacetime to produce warp-like travel, as previously indicated in the years later. The goal of the studies that follow is to improve and deal with a few issues, the Alcubierre warp drive, such that given the massive energy needs and the contradictions related to time journey, theorists and scientists struggled with the implications for theory investigating if a propulsion system like that could ever come to pass. Chemical rockets, although they could be useful, appear somewhat archaic when they are broken down. You fill up a ton with liquid or fuel solid, add an oxidizer, and turn everything on fire, and allow the gases that explode to supply the motivation required to launch a rocket the opposite way, though they're ineffective. For instance, the Falcon Heavy is a monstrous creature weighing 550 metric tons. It has a fuel capacity of almost 400 tons, and first stage of the oxidizer burns for only 162 seconds, during which the second 397 seconds in total, or roughly 9.5 burn time in minutes. Due to this inefficiency, has inspired researchers to investigate substitute methods of propulsion, particularly for extended space travel. But Alcubierre's suggestion has been beneficial. Us advance in creating concepts similar to warp drives and ion drives. One of thus far the most promising solutions are these ion drives. Ion thruster, comparatively sluggish, but extremely fuel efficient, which makes them a viable choice for different space missions. But the majority of powerful chemical rockets that emit heat gases at a speed of roughly 5 chem/ in multiple second ion engines accelerated notches by releasing single atoms at a speed of 90 kilometers per second. This increased speed results in a vastly more effective speeding up, while the ideal chemical rockets have an efficiency of about 35. Ion engines have an astounding 90. These engines have a day-long runtime. Weeks or even months on end, non-stop long after chemical rockets. Acceleration would have consumed all of their gasoline, so once the planet's gravity well is beyond you. They develop into extraordinarily effective instruments for drastically altering the speed. Several space agencies, including NASA, have adopted ion engines with remarkable achievement throughout numerous missions, even though they continue to search for better options. Played around with the idea of a thruster for decades, but at first was hesitant to use it in ongoing missions because of the possible dangers that could arise. All of that was altered by NASA's Deep Space One mission, was initiated in 1998. This spacecraft was full of boldness. Technologies such as low-power solar concentrator arrays with electronic scientific tools, as well as the engine's electric propulsion system, was run for a long time, enabling it to conduct close examinations of comets, asteroids, and even Mars. Expanding on one's victories in deep space, NASA's Dawn mission advanced it further. With 3 ion engines and redundant, the spacecraft was able to use these engines to orbit Vesta, the asteroid, and collect data, then depart from orbit and approach the asteroid series for further investigation. Amazingly, there may be fuel left. Departed for further asteroid visits to provide you with an idea of their speed. Sunrise times range from 0 to 100 kilometers in just 4 days of non-stop use. Pushing. Additionally, ion thrusters have been used in more missions, including the intelligent one of ESA. They were used by spacecraft to travel from lunar orbit to Earth orbit, and the Japanese spacecraft Hayabusa depended on ion engines are so powerful that they have even subjected to intense testing on Earth, where they were operational for greater than 5 years. Like these victories weren't thrilling enough sufficient, there will be even more in the future. Optimism regarding ion thrusters. Scholars are investigating methods to improve their output. One strategy is to greatly expand the quantity of the ions are accelerated by electricity. At one point, NASA considered a mission named the Orbiter of Jupiter's icy moons, powered by the 10-ion nuclear electric system engine that was capable of investigation ion thrusters on Jupiter's moons, but the mission was shelved in the past. 2005. Another path entails creating versions of ion engines with high thrust, such as NASA's Hull thruster, the X-3 generating 5.4 Newton force, noteworthy change from the thousandths of newtons, as observed in earlier thrusters. With its full potential, this technology could the duration of human astronauts' flights visiting Mars. For a brief period of time, engineers are preparing for a 100-hour shift. Tests of the X-3 to evaluate its durability, operational capacities of the European. Additionally, Space Agency is experimenting with an ion engine that breathes air in place of carrying so much fuel. This engine would absorb air molecules from the low Earth orbit atmosphere, ionize, then drive them out. Because the spacecraft would be able to plenty of solar power, and it could function using atmospheric propellant for long stretches of time without refueling. This invention has the potential to transform spaceflight, enables spacecraft to operate in space, and at lower altitude stations will continue to orbit low on Earth forever without the need for recurring enhances. One of these revolutionary when it comes to technologies, the ion drive. Ion drives were first proposed. Many critics said it couldn't produce sufficient force to propel a spacecraft, but as it happens, ion drives are not merely hypothetical. They are practical. NASA acknowledged their capabilities and in 2016 granted a substantial contract to Rocketdyne Aerojet to create a cutting-edge solar electric propulsion system, which is also referred to as the Hall effect, which thruster uses generating electricity from solar power and after that accelerating ions with it, which consequently produces thrust, using the degree of advancement that the ion drive has as time goes on. Some may question why not much has been accomplished in the use of warp drives. That is, there are a few of anomalies in the theory of warp drive. Scientists are still figuring things out. Their minds attempting to determine how to invoke one of these cool warps bubbles in an area that's not previously possessed one, and even if they were able to perform the bubble trick, it's not real. As soon as you're cruising, Exit strategy within the warp bubble. There are unknown how to depart gracefully. In 2012, Eagleworks even determined that it was time to investigate the potential use of. They created a warp drive and the interferometer, a device made to detect any odd spatial distortions brought about by the growing and space-time contraction of the Alcubierre metric. But all of this resulted in an impasse. Most likely in the future, scientists will eventually comprehend how to assist humans by using warp drives, investigate deep space. Currently piqued interest have switched from ion to nuclear thrusters. Thermal power plants. Recently, there was a partnership between DARPA and NASA, the Advanced Defense Agency for Research Projects. This partnership, referred to as the Test Rocket for Flexible CIS Lunar, either Draco, seeks to expedite the creation of this space-age engine. The intended use of this advanced nuclear thermal propulsion mechanism powered by 2027. With this cheap new technology, astronauts could quickly go to and from deep space. Nuclear thermal rockets that travel to space quickly reduce the amount of time needed to get places, and it's significant when you're discussing locations all the way to Mars. Extended journeys require more supplies and more complex systems, and we would prefer to maintain things are more organized. But there's still more than just nuclear thermal speed. There are additional benefits that rockets enhance. The ability to carry out scientific missions and provide tools and a means of communication systems with greater power to operate at these rockets' cores contain a fission reactor that produces extraordinarily high temperatures, at which this heat is then moved to a unique liquid propellant. In instances where it is discharged via a nozzle, it grows and launches, accelerating the spacecraft moving forward. A high-tech method of attaining propulsion, and have three possible many times more effective than traditional chemical techniques. The space domain has greater importance than ever, having an effect on everything, including commerce to scientific advancement, and national. These developments in space security technology, via the nuclear Draco, the thermal rocket program, will enable delivering supplies to the moon, and eventually sending more effective humans to Mars and quicker. It's crucial to remember that when was the last time the U.S. used a nuclear thermal rocket engine test, conducted more than 50 years ago. Working together is a big step. Advances in nuclear technology for space travel. Latest developments in aerospace engineering and materials are bringing in a new age, preparing the ground for an Earth-Moon economy. But the cooperation continues beyond this point, as the Department of Industry and Energy (DOE) are focusing on numerous programs to use nuclear ability to explore space. They're generating ideas for nuclear power utilizable plants on the moon, and these initiatives on Mars are a part of the larger intent to enhance engine efficiency and support the long-term change space. Certain people's exploration objectives questioned why NASA switched from ion drivetrains for this new nuclear development that appears to be illegal. Of physics, including plasma and ion thrusters, certainly have advantages, but they also come with a few noteworthy disadvantages that needs to be taken into account. As already stated, that they experience a notably low average thrust, which implies they are unable to offer the type of powerful propulsion that conventional chemical rockets provide. Additionally, the thrusters require a significant electrical power, typically in the tens of from several megawatts to kilowatts, from an angle that's similar to having a powerful and insatiably energized continuous operation of the appliance. This presents a problem since producing and keeping such big, there isn't much electricity in space. Modest achievement. In addition to the problem of possible ion and plasma contamination, the use of thrusters can result in contaminating the outside of the spacecraft with materials such as cesium or mercury. This contamination may cause issues for a number of reasons, such as possible harm to delicate equipment, and on the other hand, nuclear equipment on board thermal engines provide a noteworthy benefit in terms of thrust, when unlike ion thrusters, they are able to give the sudden surge of energy required to swiftly advance a spacecraft when hydrogen, more especially liquid hydrogen, the propellant in these, is low too. Motors have a greater specific impulse, as well as a higher exhaust velocity than conventional chemical ignites. This leads to increased effectiveness, as the spacecraft can travel farther by employing less fuel. But it's crucial to remember that even though it's more effective, efficiency leap of a quantum in a vacuum nuclear thermal engines surroundings the capacity to provide a reduced empty weight of the car and a greater percentage of payload. Similar to the engine getting rid of extra baggage and making the most of their cargo space, this characteristic is especially beneficial for lengthy missions wherein each kilogram of payload is significant essentially, although ions and plasma thrusters had advantages of their own. Nuclear thermal engines replace their increased thrust capacities, and benefits of efficiency are what matter most. Selecting the appropriate tool for the task and assessing the benefits and drawbacks to make sure the accomplishments of space missions. This is not to say that these engines don't have difficulties after that nuclear core is operational and getting close to it turns into a dangerous undertaking and the surrounding support structures become intensely radioactive crew members, and most robots can't get anywhere near it. They must maintain a safe distance of several hundred meters, which adds to the overall weight and complexity of the spacecraft. Beyond this, there are other problems this rocket engine poses, but scientists keep working to make it better. NASA and DARPA's collaboration aims to make space missions more efficient and set the stage for a new era of space exploration. Thanks for watching. If you enjoy this video, then click on the link appearing on your screen right now. It will lead you to another one of our interesting videos. See you there.